Dear students, how are you? First of all, welcome to class 10th and accept my heartiest congratulations for your hard work. Because of your hard work, you are now in class 10th, and I am sure that this hard work will continue in class 10th. Now, I am going to start the first session of physics for class 10th, and in first we are going to study about electricity. And electricity is the first chapter. It is very important because electricity is related to our daily life. We are using electricity in our daily life, and in higher classes also you will continue to study this chapter. So first of all, what is electricity? Electricity is nothing. It is simply the flow of charges. So electricity is the energy which is possessed by the flowing charges. Charge energy, because energy, why do we say energy? We know that energy, what is energy? Capacity to do work. Electricity used to perform many work in our daily life. So now after this, when we say that it is the charges, flowing charges, so what is the charge? This question comes to our mind, that what is the charge? So charge is a basic property of matter by virtue of which it attract or repel matter of its kind. In lower classes, you must have done this activity when you rub your this plastic scale with your dry hair, and if you bring it near small paper bits, then these paper bits are attracted by the plastic scale. So this shows that the scale is charged and it is attracting the paper bits. So it is a simple property. And balloon activity also, when you rub balloon with your dry hair, and when you just bring it to close to the wall, then it sticks to wall. So there are properties of charges, some properties of charges. The properties of charge, first is like mass. It is fundamental property of matter. It is present in each and every substance in the universe. It is a scalar quantity because it doesn't have any direction. It has only number. Its unit is Coulomb. It was discovered by Coulomb, so its unit has been named after him. Its unit is Coulomb. Now, first topic is this: how charge is produced. Just I discussed that when plastic scale is rubbed with the dry hair, it gets charged. So how is charge produced? Charge is produced through the transfer of elementary particles known as electrons. So on rubbing, what happens? These electrons are transferred from one body to another body. So because we know that an atom, it is made up of three fundamental particles: neutrons, protons and electrons. But out of these three, electrons can be transferred from one atom to another atom, from one body to another body. So therefore it is a transfer of electrons. Charge is represented by Q, and it is equal to plus minus, here sign is there, N into E. Why plus and minus? Because plus if it is proton, negative for electron. N is the number, how many electrons are being transferred out. Now E is the charge. The magnitude of charge on one electron, it is minus 1.6 into 10 raised to the power minus 19 Coulomb. So here this minus shows that it is for electron, charge on electron, and for proton it is positive. Charge on n electrons will be then minus n into E, or n into this 1.6 into 10 raised to the power 19. E is the charge. How many charges are there? And if two number charges are there, then 2 into 1.6, 3 into 1.6. N is the number of electrons, just I explained. And n can never be in fraction. It is a whole number. It is a complete number. It can be 1, 2, 3, 4, 5, any number. And a substance can have two type of charges. Positive charge, it has a deficiency of electron. If a body is having deficiency of electrons, then it is said to be positive charge. Then protons are more on that body. Protons are positively charged, so therefore protons are more in number, so therefore that body is said to be positively charged. A negative charge, it has an excess of electron. So when a body is having negative charge, so we say that it has excess of electrons. This means it has taken electrons from another body. So therefore it has excess of electrons. So electrons are more than positive particles, protons. So it is said to be negatively charged body. Now after this, What happens what happens when these charges are at rest or are flowing? So electricity, actually this is of two types: electric current, static, and current. Electric current. So we are going to study about the electric current. Current means flowing. Current means motion. So electric current, we are going to study, but not about the static electricity. We are going to study current electricity. So electric current is a time rate of flow of electric charges through a conductor. Conductor is very important. Conductor, it cannot pass through insulators. Okay, so therefore conductor. What is important here? When a potential difference is applied between its and is okay. Now electric current, how do we represent it here in the form of formula? It is the charges, total charge upon time, because it is time rate. Time rate means numerator and denominator. So numerator upon denominator. How do we represent? What is a unit of electric current? This question comes to our mind. So SI unit of electric current is ampere. SI unit is ampere. It is represented by capital A. It has been named after Andre Marie Ampere, who discovered it. So to just give honor to him, it has been named after him. 1 coulomb of charge, it is equal to 1 ampere charge is equal to 1 coulomb upon 1 second. Now current flows from higher potential to lower potential. We shall be studying in second session about potential. It cannot flow in absence of potential difference. If you are using a dead cell with zero potential, then and you are using it, electric current will never flow through the conductor. Electric potential is a cause and electric current is an effect of potential difference. If potential difference is there, only then electric current will flow. In absence of a battery or a cell, electric current cannot flow through a conductor. Now again, in electric current, what is the definition of 1 ampere? How will you define 1 ampere? 1 ampere is a current when 1 coulomb charge flows through a cross-sectional area of a conductor in 1 second. Cross-sectional area. So here this portion is showing cross-section. How many electrons are passing through this in 1 second? So this is representing here cross-sectional. From this given area, how many electrons are passing through? And these are smaller units: milliampere 10 raised to minus 3, micro 10 raised to minus 6A. Electric current in terms of number of electrons. So before this we studied about I is equal to Q upon T, charge upon time. Here Q is equal to N into E. This we have done in earlier slides. So total charge passing through a cross-sectional area is equal to N into E. Right. Now electric current is a scalar quantity because on changing its direction, its strength is not changed. In class 9th you have done when two forces are acting on a body in different directions, then what happens? So on changing the direction of electric current, its magnitude is not changed, so therefore it is a scalar quantity. Now this is one example how to solve numerical. Calculate the number of electrons present in 1 coulomb. So here given, it is must. First of all you should write given, then to find, I have not mentioned here, and then solution. 1 coulomb charge is here. Charge on 1 electron is this. Since we know that, we should write in numericals or in some answers also. Q is equal to Ne. Using this, here we can solve. Here what I have done, 10 raised to power minus 19. 19 directly it has been taken to denominator. Simple mathematics. Mathematics is very important. Here 10 upon 16 I have done, because point has been removed. It becomes 10. I am taking 1 0 from this side to this, and it becomes 100. So 100 upon 16 into 10 raised to 18, it becomes 6.25 10 raised to power 18. Now these are some numericals. I am sure you will be doing practice, and in board exam you will be getting one numerical. Okay. Now how electric current is measured? This question is generally asked. You should know how do we measure electric current. To measure electric current passing through a circuit, passing through a conductor, we use a device known as ammeter. A for ammeter and A for ampere. So simply it is very easy to remember. A for ampere, A for ammeter means this device is used to measure amperes, means strength of current passing through a conductor. A meter of minimum least count measures current more accurately, because if least count is minimum, you know what is least count, I shall be discussing in next topic also. So least count, minimum, how much current is passing, minimum current it should measure, therefore it should have least count. Precaution should be taken while using ammeter. It should never be used in parallel in electric circuits, because a good ammeter has low resistance. So when large amount of current will pass through it, and when it is in parallel, we shall be studying in electric circuits, then high amount of current will damage the ammeter. Now it is connected in series in electric circuits always, because it has to measure the total current passing through the conductor. So plus is of ammeter should be connected to plus of cell or battery. Positive, plus means positive. Negative of it should be connected to negative of cell or battery which we are using. And characteristics, again, it should have low resistance, we have discussed. To allow large amount of current, if it has low resistance, the resist means to oppose. It will not give opposition to the flow of electrons, so it will measure current passing the conductor very accurately. And an ideal ammeter should have zero resistance. When zero resistance there, then it will allow whole of the current which is being given to the circuit. Now, least count of ammeter, and here it is the minimum value of electric current measured by an ammeter, minimum, smallest. So if here you can see from 1 to 2, 0 to 2, if 20 divisions are there, then what will be the least count? So 2 upon 20, then it will be 2 upon 20 means 1 upon 10 is equal to 0.1. Now range of ammeter here in this is the second case. Here you can see it is 0, and if we come to 50, its range is 0 to 50, means it can measure up to 50 ampere of current. And here this ammeter, it can measure 0 to 10 ampere of current. Got it? Now least count formula, least count is equal to range of ammeter. Here E is missing here. Total number of divisions. So here in second case, here 50 is total is 0 to 50, upon 50 divisions are there. Therefore it comes out to be 1 ampere. We can find by using this method also 0 to 10, range is 0 to 10, so 10 minus 0, and here 10 is divided by how many divisions are there? 10. Here red mark is showing, this red line is showing 5. So total 10 divisions, 10 upon 10 is equal to 1 ampere. It's very easy. Ammeter is used in labs also. When you will be doing experiment, you will be using it. So here reading of ammeter, what will be the reading of ammeter here? Needle is here. So this number of division into least count. Number of divisions are how many? 9 divisions are. It is on 9th division. Least count is 1. So therefore it will be 9 into 1 ampere. Now this was for first session. And in second session we shall be talking about the potential difference, voltmeter, and then Ohm's law. So till now, thank you, and I'm sure you must have enjoyed, and do revise at home. God bless you.